So I'm going to turn it over to Eric Niiler, and so he'll be the moderator for this Spaceside chat. Eric Niiler is a contributing writer at Wired, covering science and technology. And he also teaches science writing at Johns Hopkins University. Eric?
Hi, hello everyone. Greetings. Good afternoon. It's my honor to welcome an amazing group of leaders in geospatial technology and exploration. Each one of them are pushing the boundaries of what can be learned about Earth, its environment, and its inhabitants from satellites in orbit. Today, we're going to learn a little bit more about their individual career pathways, how space-based imaging is changing our lives, and what may lie ahead. First, we have Dr. Stacey Dixon. She is the Deputy Director of the National Geospatial-Intelligence Agency. We also have Dr. Sarah Parcak. She is an author and a space archaeologist at the University of Alabama at Birmingham. And Robbie Schingler. He's the co-founder and chief strategy officer of Planet. Welcome, everyone.
Thank you.
Good to be here.
So I thought we'd start out a little bit today with how you got to where you are now. I think there are going to be a lot of folks out there in different stages of their career paths. There may be students out there. There may be people who want to change careers. I thought we could give a little bit of a background. And so I'd like to know how each of one of you got into this field and why you started thinking about space as a way to observe Earth. I can see Stacey first on my little cube here. So I'm going to go ahead and start with you. Tell us a little bit about yourself.
Thanks, Eric. So I'm an engineer by training, and I actually started off my career looking inside. So I was looking at mechanical properties of arteries. But you find yourself at a career crossroads, and you find yourself at a life crossroads. And the recession of 2002, a desire to do something slightly different than what I had been doing in my academic career made me stumble into the intelligence community. And I ended up working on building satellites as my first job. And so I really did stumble into geospatial intelligence, but it's been quite a ride since then. And learning more and more about the capabilities out there. So I'm really excited about this panel and sharing what we understand and learning about what's to come.
Sarah, you've had an amazing career around the world looking at all kinds of things, from outer space, things in the background there from Egypt to now Peru. How did you stumble in from archaeology to space archaeology?
So my story is a family one. So my grandfather, Harold Young, was a professor at the University of Maine in Orono. He was a forestry professor, and he was one of the pioneers of using aerial photogrammetry in forestry. He was a paratrooper in World War II for the Screaming Eagles, a captain, highly decorated, and he at the time received state-of-the-art technology, which were a series of aerial photos that he carried around in his pocket, so after he landed, he could reconnect with his platoon. And he took that knowledge with him when he got his PhD, and so he developed a career applying this new state-of-the-art technology. And he's the reason I took my first remote sensing course as an undergraduate at Yale back in 2001. At that point, I thought, wow. Well, unfortunately, at that point, he passed away from cancer. But I wondered, I bet loads of people have used satellites in archaeology. It'd be fun to learn more about what my grandfather did. And so I took a course the second semester of my senior year that literally changed my life and my career trajectory. So for any students watching right now, whether you're undergrad or grad student or postdoc, definitely take that course. It's never too late to change. And I realized taking the course, wow, hardly anyone has applied this to archaeology and especially Egypt. And so I developed my PhD around looking at new techniques for finding sites in Egypt, and that's really what got me started. So yeah, it was my grandfather.
Robbie, you were studying physics and engineering, and then you went into business and space. How did you, what drew you to, building a business in space?
Yeah, so I guess to share more also earlier on in my career, I've always been a space geek and a physicist by training. and lucky enough to be an intern at NASA for my last 2 years of undergrad, but really as a researcher, doing cosmochemistry work to try to understand how organic life evolves in the cosmos and universe. But what really shifted for me was going to France right after I graduated undergrad, and I went to the International Space University to do a master's in space studies, which really teaches a systems approach to the space sector, from what happens to the human body in space to how rockets are made, satellites are built, and the business of space, and also the geopolitics of it. And through there, I kind of ended up meeting my community, my space tribe. This was back in 2000. So for the last 20 years or so, I've been playing with a number of different space projects, from working on space security to going to NASA, working on new missions. I worked on incubating a mission called TESS, the Transiting Exoplanet Survey Satellite, to look for stars around, or look for planets around other stars. And about 8 years ago, left with two of my really good friends to start Planet. And the motivation behind that was to recognize that technology development, team dynamics can be different than the way that we currently build space systems inside the aerospace industry. So we pioneered agile aerospace, and over the last 8 years have launched over 400 satellites, and we've built a business on top of this in order to image the whole world every day, and make that data available to just about every sector across the society, so that we can understand what's happening on the planet, anticipate what's about to happen to make better decisions. So my passion for space has really been from a kid. And bringing about that planetary perspective to recognize how interrelated we all are as denizens of planet Earth, and some of the challenges that we have over the course of the 21st century, wicked problems, in order to become planetary stewards, so that we can sustainably make it through the century. That's my motivation.
What are some of the challenges that each of you are facing right now? You know, we're all, everyone's facing the pandemic, and some of us are having to change the way we do business, the way we collect information, the way we share with our teams. I wonder if there's something fundamental that's changed, or we're all just hunkering down right now.
I'll start with this one. So with us, we've gone from hosting a couple hundred of people online doing telework to having 8,000 on average in any given day. So it really has fundamentally changed the way that we're doing geospatial intelligence and what data we're working with. Having access to commercial satellite imagery and publicly available data has been an amazing game changer in this period of time, especially. We already had it incorporated into our missions, but being able to use it now to the extent that we've been able to use it to allow our families and our workforce to stay at home safely during this time period and still do very meaningful work for the intelligence community has been just wonderful. So we've been able to really accomplish a lot of things because of our ability to ramp up very quickly, get the IT architecture in place, but then to have the data that we're able to use and to bring the tools to the unclassified side to be able to do the work. So for us, it's been a huge change, and we foresee ourselves continuing with this after COVID, going back. We won't go back to the way we were before. We'll figure out the better balance between unclassified aspects of our mission and the classified aspects.
And Sarah, how's it affecting a scientist like yourself who relies on so many collaborations with people on the ground?
I mean, like everyone,
space.
Yeah, of course, you know, travel has been curtailed quite heavily. We were supposed to go out to Egypt in May to have a really big dig season. You know, we're very lucky in that most of the processing work that we do is, of course, remote. The new version of the platform, which we're currently redeveloping, we can do all of that work remotely, and we're in a good position in that, you know, we're working very closely with the Ministry of Culture, the Archaeological Survey of India, as well as the Tata Trust, who are very generously supporting our efforts. And because what we're doing is remote, and because students across India are going to be able to use our platform, whereas other projects that rely kind of on groundwork may have been delayed, ours is at least we've got a chance to kind of push ahead. You know, we're rethinking how we do our work in Egypt. We've had to. I'm very lucky in that my mission, or my project, not my project, our project is a joint mission with the Ministry of Antiquities. So that means I have equal numbers of Egyptian and foreign team collaborators. And it means that, that because we've signed, we've signed agreements in the past, my collaborators can do work on the ground safely. The situation in Egypt is quite a bit better than the situation in the US. And so any groundwork can be done safely and socially distanced. So we're hopefully going to be pushing ahead with doing some aspects of the project remotely. And the question is, of course, depending on the length of the pandemic, is it possible to do any work there? Is it possible to travel safely? And these are big, difficult ethical questions, and the reality is we can't quite answer them yet. But we're all kind of doing the best we can, but at least there's some parts of the work that we can do, and it's being done safely.
And Robbie, how has this changed how you've dealt with both your firm that you've built up, and then also with the clients that you have, the public and the private clients?
Yeah, so beginning of the year, before the lockdown, it was quite clear that we had a busy year with respect to a number of satellites to build and to launch and to commission, and it's really hard to build hardware remotely. So right away, we at Planet we kind of shut down, went to remote work, except for satellite manufacturing, about 2 weeks before lockdown, and we've been able to stay up. So we've, over the course of the last 6 months, we've been on 4 different launch vehicles, launch campaigns, launched 38 satellites, and are building. We've got another launch coming up in the next couple of weeks, actually a week, with another 12 satellites on it, and then another one in December, and that one will have 48. So the team's busy and working, and we shifted to remote work seamlessly. Because of the way that we architected our company to be more of a cloud-first, remote-friendly organization, and to have that done in a very secure way. So we didn't skip a beat in delivering services to our customers. I would say probably in the springtime, there was a little bit of slowdown, and then it sped up quite a bit with respect to demand for remote sensing products. Really, it seems like COVID has just accelerated some things that were already kind of like happening under the surface. And modifying one's workflow to use modern tools that allow for people to then make decisions faster and anticipate what's happening is something that we already have been seeing quite a bit in our customer base, and now it is quite accelerating in demand as people are having to deploy and take on new tools that they aren't necessarily used to doing, then now recognizing that they can be way more efficient in their work. So we see our sector in remote sensing actually being really quite critical to the new reality of where we are today as a planet.
One of the questions we've already gotten here is from someone who'd like to hear about this private and public collaboration, Robbie, as your satellites go up on SpaceX flights, but they serve both public and private clients. On how is that model changing right now? I'm kind of curious who's in charge up there.
Fascinating. Well, there's a lot that we can unpack there. The question from the audience is spot on, which is there seems to be a bit of a transition that's happening within the space community. And I would say that we're about 5 years into a 10-year transition. And if you've heard me say that before for the last couple of years, I think I'm still in right. So it is taking a bit longer. Maybe it's more like a dozen years of transition. But let's talk about, so first of all, we're a commercial company. If we want to get access to space, we have to pay to have access to space. And so we pay SpaceX. We're their customer in order to get access to space when we go up, just like anything else. But I think the private-public collaboration piece is the interesting part to dig in on. I'd love to hear what Stacey has to say about it too, and what you see. But here's the bottom line: is that there are new companies that are delivering space-based services that can serve government, civil, in addition to commercial, nonprofit, academic needs. And that's not necessarily how the government is used to using space-related services. They're used to building and owning and operating their own services that they have complete control over. And but the cat's out of the bag, right? I think two major trends happened in the 2010s. One is reusable rockets, which finally, only about a year ago, we have a decrease in cost. And that happened when SpaceX changed their cost for secondary payloads. And two is something that we pioneered at Planet, which is to mass manufacture satellites that have a high performance per unit cost ratio, and to operate them in an autonomous way, in a way that every year we launch a third of the fleet, so that we then continuously upgrade a capability, and you end up having a constellation that provides a space-based service that then can serve many customers. And so I think that that's where the public and private engagements are right now, which is there are commercial products that the public market or government can purchase. They're just not used to purchasing in that way. And so it takes a partnership in order to earn trust, make sure that it's reliable, make sure that you have a service level agreement, to make sure that it is consistent, and you can rely on it into operations. And we've had a long-standing partnership with NGA for the last 5 years. That trust has been developed over time, and now we actually understand each other's needs as well as capabilities. That we as a company who have customers like NGA but all over the world can listen to the commonalities and then choose what's the next major feature that we upgrade in our service. So we're shifting from one-off projects to more space-based services, and that's a fundamental shift and an awesome opportunity for entrepreneurs around the world.
Stacey, I wonder if you could talk a little bit about any partnerships that NGA has with private companies like Planet, but I also want to know more about NGA because I ride my bicycle past that building a lot of times, and I'm wondering what's inside. And so for those in the audience like myself who don't know a lot about NGA, maybe if you could tell us a little bit about that and then the partnerships.
Absolutely. So we have this amazing, what I would consider an amazing mission to be able to work with partners, whether they're in the Department of Defense or the intelligence community. We have a role supporting humanitarian disasters as well, and in support of organizations like FEMA. Right now we have an effort helping out with some of the fires out in California and in New Mexico, Colorado. So we actually have quite of a broad mission, but we leverage imagery coming from space, whether it is a nationally owned system. We don't own the systems. We work with the National Reconnaissance Office as our intelligence community partner, but as well as with commercial sector partners like Planet and others to be able to provide us the data we need. And Robbie's really correct in that we did for a long time own the systems, and we controlled them, and we had those satellites, and when those satellites were overhead and collecting, that's the data we had. There is a beauty in being able to have a larger constellation that we don't own that has all of these other satellites that are owned by others, but which we can either purchase an image or we can purchase a service. And so we are sort of recalibrating what our investment will be going forward into the future to be able to access it. It's not that we need all the data. We need the data of those things that we need the data of. And while we can't predict what that is all the time, knowing the constellations, knowing what's overhead at any given time, we can do a better job of tipping and queuing between the systems so that we know that something's happening, and then we can automatically collect whatever is overhead to be able to use that for whoever our partner is. So our goal is to get faster, to be able to provide that accurate geospatial intelligence that's needed, where it's needed, when it's needed to the customer. And depending on what the mission is, you may need it in seconds, you may need it in hours, you may need it in days. But we want to be able to provide it when it's needed for our partner. And certainly commercial imagery companies are a huge part of that to help us accomplish that part of our mission. So it's a fun mission. I love the fact that we can help out when there are challenges all over the world, whether hurricane, fires, earthquakes, and also be able to help from the national security perspective of keeping our country safe. So our building in Springfield has about half of our workforce, and it's everything from the folks that actually keep the building running, all the way to analysts, to data scientists, to collection experts who know all the satellites and what they're capable of, and can basically point us to the types of things that we need to be able to answer the intelligence community questions.
Sarah, I'm curious about how scientists and NGOs who have a mission to protect resources, human resources, environmental resources, and any partnerships you've had with commercial agencies, commercial space agencies, and are there ever any times where there are conflicts where, you know, I think in your last talk, your keynote, you talked about open source data and that you had to strip away, you know, GPS data. And as the resolution gets clear and everyone can get everything, I'm just wondering a little bit about that. So your partnerships and how they can use data.
Sure. So I've been working, goodness, for 15 years with, well, first Digital Globe, now Maxar Technologies. You know, they're one of the largest, if not the largest, provider of commercial satellite imagery in the world. They were a major partner for the launch of Global Explorer. You know, if you had told me when I started off being a professor that I would be able to negotiate the intricacies of large-scale contract negotiations with multinational private corporations, I would have gone, what? No, that's absolutely not what I do. But anyway, the things you learn. But yeah, it's been wonderful to figure out kind of the private side of things and to be able to learn from my colleagues, kind of how that world works, because so much of the work that's done in science, we rely on, you know, on technologies from private companies, and being able to understand how they operate, kind of their long-term goals, how both my archaeological research and then the work I do at Global Explorer as a not-for-profit kind of fits into that longer-term mission, and then being able to help each other. So I'm on the front lines of science, so I'm able to provide them kind of insider perspectives on kind of where the field is going based on archaeological and heritage needs, and then they're able to share kind of what they can in terms of where the technology is headed, and we've been able to do white papers for them. You know, I've talked extensively to Robbie's co-founder, Will Marshall, about kind of potential collaborations as they gather more and more data. Because what I found is that satellite companies around the world, you know, yes, they're commercial, but they're so generous with their data. They're always asking, what do you need? How can we help? Everyone gets excited about archaeology and heritage, and especially, you know, given that our platform is something, it's free, it's something everyone can use. And we're trying to make it even better with machine learning. You know, we want to incorporate as much data as possible into into it, because the more data, the better. So yeah, so whether it's negotiating and working with private companies that provide this technology, you know, companies that use drones, it's absolutely essential for the work that I do and the work that my colleagues do. And I think there's now enough of us that do remote sensing or space archaeology to where it's pretty clear what our needs are in terms of next steps and mapping the world. And kind of with this consortium of scholars and scientists and working with private companies, you know, I think long term we can potentially have some influence over how satellites are developed. You know, if there's a potential for adding different parts of the light spectrum, or the potential for something like space-based LiDAR, you know, it would be extraordinary to partner on a satellite that could serve multiple industries. So yeah, I'm very excited about kind of where industry is headed. We need all the data from you know, very high resolution commercial satellites at Maxar to you know, amazing companies like Planet that are cross kind of bridging that gap. They're collecting so many thousands and thousands of satellite images every day, and they're able to respond with speed. And so we could work with them, say, on monitoring sites that are being looted and get that rapid response information that we so need. So yeah, I'm very excited about where things are headed.
That'll kind of brings me to my next question about technology development and where we're headed, both with the satellite platforms, which can take a long time to develop, and the kinds of sensors and cameras that seem to be just going so quickly. And new companies are announcing new capabilities all the time. So I wonder, Robbie, if you could kick that off, and let's just talk a little bit about what we're going to see in the next 5 to 10 years in satellite capability, but also sensing?
Awesome. Thank you for that question. I'm super excited. 2020s are going to be fun. You know, as I was mentioning before, access to space has come down quite a bit for large payloads, right? And so while what happened in the 2010s is there was a revolution that had in access to space for things that are known as secondary payloads. So getting access to space as kind of like hitching a ride. Now with these investments in large lift, payloads are going to be really big, which then means that you can reimagine your space infrastructure a little bit better. If you take a look at what you know, Google has done 20 years ago, is that they took commodity hardware. Remember when you used to actually like build your own, you know, desktop computers? Well, they took that type of stuff and built out a distributed cloud computing capability, and pioneered new things like zero trust architecture and security. And that was that was the thing that really kind of was the engine under the hood for them that built their search and advertising giant. And I think some of those things are going to happen again in space. So here's a couple of things that I'm most excited about, and that is space infrastructure. And the first piece of space infrastructure that's going to go up in space is a data layer. So there are about a half dozen very well-funded, very credible, a little bit different architectures from a technology standpoint of mega communications of satellites that will be, or mega constellations of satellites for communications, essentially for internet or IoT or real-time communication. Now, if you think about that, what that means is you as a satellite, you don't have to bring up a huge transponder, you can just bring a cell phone. Right? So it's then easier for you to then build a new application to then plug into that infrastructure that's up in space. Mm-hmm. And so I think over the course of the 2020s, we're going to see this trend continue of not in public-private partnerships, not only as public-private partnerships, but actually as the public sector purchases planetary scale products and services. Because if you are delivering telco to, let's say, the United States via a constellation of these satellites, space is unique in that it's a global market. And so you can take that same exact asset and then do that to every single country on the planet. And so that's one major trend that I think is going to be really cool is satellite architects are going to be able to rethink through missions now that cost per kilogram is way lower, and that automation has increased a lot, which then allows for you to then operate a distributed constellation of sensors in space autonomously and cost effectively. And it's going to decrease the barrier to entry for new products and services. So entrepreneurs out there they don't have to be an aerospace engineer, right? There's now enough of the supply chain that frankly didn't exist when we started our company 8 years ago, that really allow for innovation to accelerate. So it doesn't have to take 5 years to get your first mission in space. In fact, if you don't get your first mission in space or tested in 12 months to 18 months, like think again, because that's not the development cycle that's going to have you have an advantage. And then, yeah, so those are some of the things when it comes to near Earth space. I think that's going to be a trend, is more planetary scale terrestrial services delivered from space-based assets. And that could be for weather, it could be for Earth observation and monitoring, which is what we do at Planet. It can be for internet and telecommunications. It can be for position, navigation and control, IoT sensors, etc. So it's going to be a pretty exciting time. And then of course there's all the exploration stuff and the moon and what's happening there that we can spend a lot of time on.
So we got some questions from the audience, and I'd like to get to them before we start expiring here. One is about visual clarity of imagery with reduced emissions. I don't know, Sarah, you look at imagery from around the world, and I'm wondering if you're seeing any of that effect, or is that just a little blip for a few months? Anything on that?
Yeah, so yeah, with regards to COVID, I know colleagues of mine are doing a lot of work around kind of air quality, and I think certainly in the first number of months, sort of March through June, there were pretty serious changes in overall air quality. And, you know, friends of mine were posting pictures from Delhi where I've spent time, and even in the nicest time of year, it's you know, it can sometimes have poor air quality and beautiful blue skies. I think now that there's this sort of in between where we're kind of getting back and we kind of aren't, even though we're still working from home. There are still changes, and of course, what we didn't have as much before of was air travel, and now air travel is picking up again. So, you know, I think there'll be a lot of papers that will be published next year that talk about the changes over time. But I think what it has done, it's given us all time to kind of pause and really see in real time what happens when we pull back, and just to see sort of short-term effects of how we impact our planet. You know, there's that great hashtag you saw on social media, you know, nature is healing. You see gangs of animals wandering down streets, but we realize we, in so many cases, have, you know, we're not the animals in the right habitat. So I think hopefully, given all these images we've seen and given these changes, it's maybe hopefully around the world, you know, maybe people think longer term, gee, maybe I don't need to eat as much meat. Maybe I need to think about transitioning to a car like a Tesla, or focusing more on public transportation. So yeah, I think it's just given us all a lot more time to think about our environment and our impact. And of course, satellites have helped us to see that.
Well, I'm glad you brought up the Tesla, and I'm going to throw this one actually to Stacey about updating satellites. Like a car's updated its software, the Tesla is the first one to really do that. And I'm wondering, you don't own all these satellites, the NGA, but you sort of use a lot. And I imagine that's kind of a big thing going forward. And so the question is, where are we with real-time, over-the-air software updates on satellites on the spectrum of going from a Ford Pinto to a Tesla Model 3?
I was wondering how you were going to loop in that Tesla.
I know, I'm glad. Well, I planted that Tesla thing with Sarah.
You know, it's interesting. So you're right. We do not own the satellites themselves, but software updates are very important to them. Real-time updates, of course, right now we're dependent on ground stations and our connectivity to the satellites. So I'm not going to be able to give you a super comprehensive answer, but it is something that is important to making sure that the software is up to date, that any issues that are there can be corrected. You know, we're loading collection decks, so the things that we want to collect, we're always loading that, and the faster you can get that up and down, all the better. So things are getting better, the components are getting better, and now that the development cycles of satellites are shorter, it really does allow you to get more of the state of the art up into space more quickly. So I'm kind of excited about that one. So I don't have an exact answer for you, but things are definitely much better than they used to be, and it remains important to be able to do that.
Yeah, can I mention?
Robbie, yeah, go ahead.
So I think today most satellites are kind of like a Tesla Model 3 already, right? Which means that you are connected to it, you can talk to it, and you can reprogram what it does. I think when it comes to like real-time over-the-air updates, that's when the Tesla Model 3 is completely automated, right? Completely driverless. And that's on the near future. For real-time, it means you have to have space-to-space comms instead of waiting to go over your ground station. So that's exactly what Stacey was saying. But and then that allows for you to do over-the-air updates. Long and short is it's kind of already here. But what's exciting about it is not only just the connectivity, but is compute at the edge. So when you end up having at your sensor in nanoseconds, the second that you actually collect that information, you can then look for the things that really matter. And then so you can have an alert that's just looking for those things that move or that care about or that is something of interest. And then it goes straight to space comms. And that's when we end up getting near real-time connectivity. And by the middle of this decade, that should be a matter of course.
Would you have some kind of with your constellation, would you have like the mother or father or, lead satellite that would then distribute, upload.
Master slaves. Yeah, I mean, like, honestly, this is just computer architecture. And we've seen this over the last 40, 50 years of going from like large mainframe to like PCs to now back to cloud, which is, a big mega thing. And then now back to distributed sensor network with compute at the edge. So we've seen this quite a bit between master and slave. There's really good redundancies around allowing for a whole bunch of slaves that are out there in the computer IT architecture, obviously. But yeah, no, I do think that I can see missions where you would want to have a master and slave, and that would probably work if you are taking a flotilla to, like, let's say to Mars. You'll have one larger one that can communicate everything back, and you've got a bunch of little ones that then communicate to the big larger one. So for every mission, there's an optimal architecture.
We do have a question, kind of an interesting question from Olivia. She says, I'm older, I'm interested in AI and VR. My question is there any possibility in this late stage to study and start a new career if someone has no experience in this field?
I guess I'll hop in as a professor. First of all, I'm not just a professor, I'm a lifelong learner. I love learning new things. It's never too late to start anything new. I randomly picked up golf as a hobby over the pandemic, so I'm a big fan of encouraging people to try new things. And the wonderful thing now, there's so many extraordinary free online resources, depending on whatever you want to learn. So start with things like TED Talks. There's Coursera. There are top universities that have free online introductory overviews. So before you commit to studying a completely new thing, you can take a 10-week, 15-week free online seminar. What is this? What are the kind of key developments? And if you love it, if you're like, well, I want to learn more, there are great resources. You can start getting books. And the nice thing too, that there are so many great online courses that universities offer. Certainly where I work at the University of Alabama at Birmingham, we have a number of non-traditional students, so students who have gone back with a finishing degree or doing a different degree, and we recognize fully that that not everyone can take your standard sort of 8 to 5 p.m. courses. A lot of our students work, so we have flexible and hybrid models. Of course, things have changed a lot with the pandemic. A lot is online, but we offer so many online courses, weekend courses, night courses, early morning courses. So I highly recommend kind of once you, watch some talks online, maybe take some free courses, see if this is something you're really passionate about. Check out, start with your community college. Community colleges, I tell students, it's the best place in the world to start. Get an associate's degree and then think about going to university. There may be some amazing courses there. It's not as expensive. And then think about, look into what your local universities may offer, or indeed, a lot of universities offer online courses. You don't have to enroll as a full-time student. So there are lots of options for you. And I say, go for it.
And I'm glad Olivia actually asked about AI, because I think all three of us are really excited about what machine learning and artificial intelligence can do with this discipline, with this data. So we're all really excited about where we're going to be in 5-10 years from now, being able to leverage that with compute power and then the machine learning on top of all this variety of data sources and sensors that are out there.
Okay, well, I think we're starting to wrap up here. We're going to wrap up here. It's 3:30 here in the East. And so I just want to thank each one of you for making it today. And I've learned a lot, and I hope to be in touch with all of you, and maybe, I don't know, who knows, I'll be writing about you guys here in a little bit. Be careful. So thank you very much. And great to see all of you.
Great. Thanks a lot. Take care. Bye.
Bye-bye.